All right, so I'm Danny. I'm here to talk about how do you build high quality agents with MLflow. Yeah, let's just get started. So I'm going to do a quick overview of like what is MLflow for GenAI, kind of what are all the different components that we have. I won't be able to cover everything, but hopefully I'll be able to give you a good taste of what it is. And then I'm going to go into some problems that people typically run into when they're building agents, some ideas for some solutions. Often we'll have a solution within MLflow for that as well. So specifically around how do you build the initial MVP agents, how do you debug, how do you improve the prompts, as well as how do you, what do you do when you go to prod with this agent when you have to deal with a lot of scaling issues? So how do you understand all your different traces and requests that are coming in? And then finally, there's going to be a demo component to it as well. So what is MLflow? Many of you already know MLflow in the classic ML context, but today it's actually a unified platform for building high quality ML models as well as agents. And kind of a common question that we get is like, well, like who's actually maintaining MLflow? What's the difference between the open source and the managed offering? The answer is like, Databricks is one of the main contributors, and we're committed to ensuring that really any meaningful feature that is going to deliver value is going to make its way also into open source. In fact, we're actually moving more towards like building first in open source and then moving that into managed afterwards. So yeah, that's kind of a little bit about MLflow. It's used by a ton of different users. There are thousands of enterprises already using MLflow for GenAI. And really, I personally think it's our mission to just take what are the best practices from all these different customers and distill them into a platform that really everybody else can use. But officially, our actual mission is to provide organizations with an open platform to ship high quality GenAI fast. And that's kind of hence the title of this talk. And really, I think that a lot of that is coming from, there's a lot of manual steps that you have to go through in agent development. And we're really doing a lot of kind of cutting edge research into how do we automate more and more of that. And obviously this is kind of, constantly in process. So you'll see more and more updates on the MLflow project in the upcoming months. So MLflow for GenAI kind of breaks down into four rough components. You can kind of think of this as, well, what do you do when you deploy an agent into production? So if you want to you're going to have some LLM. So there is a gateway component to MLflow that helps you manage LLM calls. You can deal with failovers there. You can manage your kind of cost controls within that gateway component. And then to call the LLM, you'll need some sort of prompts to kind of feed into that. So there's also a built-in prompt registry. And I think one of the coolest part about the prompt registry is there's also this cool automatic prompt optimization, which we'll talk about a little bit later. And then there's also the observability layer. So how do you understand like what's going wrong in your agentic call? That's kind of the tracing component. And finally, there's an eval component, whether it's kind of human manual eval or automated LLM judge eval. We kind of have solutions for both of those. And it's meant to kind of work out of the box with whatever agent that you've built today. So integrates with every kind of major agent authoring framework and LLM. It's also built on open standards. So whatever you use in MLflow, it's going to output to you open telemetry compatible data. And there's also MCP compatibility as well. So I'm not going to be able to go through everything, but this is kind of how I've typically seen customers go through building agents. So the first kind of build a working prototype passes some basic kind of vibe checks. Maybe they just kind of stop there and go straight to production, which is actually surprisingly getting more and more common these days. But more commonly, you go through some test drive, you go through human testers, you identify some quality issues, create some repro cases, you'll improve the agent in kind of a loop, and you'll continue testing. Then you'll finally get it to a good enough spot where you can get some stakeholder sign off, and then you get it to production. You actually have a monitoring story to fill as well. So each of these steps has its equivalent kind of functionality within MLflow. I won't have time to get to all of them. So I'm actually just going to mainly focus on these three. So on the tracing, on the LLM judges, as well as the prompt registry components. Okay, so some of the common problems. First, debugging an agent is hard. So, and I know this is kind of intentionally vague, but really that's kind of how the process works as well. You're kind of building the agent, you vibe check it, and you see some inconsistent output or bad output. How do you go about resolving that? And also, often at this point, you are concerned about cost. So how do you ensure that you're not going to blow your cost before you even go to prod, or you just run out of your budget? And typically, if you're doing software engineering, you're going to add a bunch of debug logging statements. And my push is instead to use this one-line MLflow autolog method. So really, there's kind of a one-line tracing integration, and this works for many different libraries out there. So in this case, it's a LangChain integration. And what do you get when you add this one line? You're going to get, let's see, it's a little hard to see, but the left side is really showing you a detailed step-by-step in this agentic call. What are all the different steps that happen? What are all the tool calls that you've made? What are the request response success and also all sorts of metadata. On the right-hand side, you can see some other information that we're surfacing across all your requests into your agent. And it also shows kind of how many tokens are actually being spent on each request and how long is each step taking. So it's generally super useful for actually debugging your traces and figuring out which are the traces that are worth your time to investigate. I mentioned that we integrate with a lot of different libraries. Here's a handful. There's always mlflow.someLibrary.autolog that you can call to. Of course, there's other ways to configure MLflow, but this is the easiest way to get started. Okay. And then the other component of it is like one of the first things people often do is try to play around with their prompts to improve their agents. And there is a built-in prompt registry within MLflow. So here you can see kind of you can register prompts, you can show them side by side. You can really do a lot in terms of like evaluating your agent and seeing which prompts are doing the best. So I have like a quick kind of set of screenshots, also a little hard to see, I think, for you guys, but I'll share a link to the slides afterwards so you can kind of take a look at it at that point. Really how this works, I have this like super dummy, just question answer this question, and I can register a prompt using this kind of mlflow.genai register prompt method. And in this case, it just says answer this question. Very, very basic. And as you might imagine, it kind of gives you like all sorts of random responses. But what I'm doing here is I give it some expected responses that I think are actually high quality responses. And then I call this method called mlflow.genai.optimize prompts. And those of you who are a little bit more plugged into eval know that JEPA is the hot thing now. We have what I think is like the easiest way to use JEPA to optimize your prompts. It's just optimize prompts, specify the JEPA prompt optimizer. And then what it's going to do is going to optimize towards a specific metric and using kind of the latest and greatest to actually produce a bunch of different candidate prompts and giving you the best one. You can see kind of one of the outputs on the right side, which is a much more detailed prompt that talks about edge cases, talks about stylistic choices. And then once you have this, you can actually run this on these different requests and show them in the UI. So you can see here that now I'm getting a lot more consistent responses. There's kind of basically the before prompt and the after prompt. You'll notice that the after prompt is very consistently just very concise, to the point, very consistent. And you can see kind of the before and after. One cool application of this, by the way, that we've seen is kind of along the lines of model distillation. So you can use a bigger model initially to power your agents, and then you can take the outputs of that, pass that in as the expected responses, and then train a cheaper model to mimic the behavior of the larger model. And we've seen that actually works often really, really well. In fact, often being obviously much cheaper, but sometimes even being the same quality or even better. So yeah, we've seen customers actually be really successful with you adopting that pattern, which helps reduce cost for your agent. Okay, so once you get to production, very common, you're going to see some sort of drift, right? You're going to see lower quality than you expected, and now you have a lot more traces to deal with. So how do you deal with that? Actually, kind of what we've seen is that these kind of multi-turn conversational applications are becoming more and more common, which really just means you have a much more complicated agent and a lot of traces to analyze. So fixing these issues can kind of feel like whack-a-mole. So how do we see people dealing with this? One of the things is actually just to start building automated evals, and I think there's layers to this. So I would just start simple. But we actually kind of just did an eval, and when we did the prompt optimization, we passed in a bunch of inputs and outputs. We said, here's like the more correct responses. And we had MLflow use an LLM to basically assess whether each response is like closer to their expected response. So we kind of already did that. Building evals early is one of the best ways to kind of quickly improve quality, especially if you can get a judge that's aligned with a human, because then you don't have to manually look at all your different requests. You can trust an LLM judge to evaluate a specific dimension across all your different kind of traces. And this also kind of opens up a lot of ways to experiment and optimize. So you could pass in more of these examples to optimize prompts, and it's going to give you a much better response as well. On the right side, you can kind of see how you get started. So there's MLflow search traces. That's how you would actually query traces that you've already ingested after you configured the autolog. You can do all sorts of slicing and dicing. And then you really just have like two methods that you create a run, which is really just the name of the current evaluation. And then you call MLflow GenAI evaluates. And then you can pass in some scores. So what is a score, you might ask? That's kind of basically our name for a judge. So we have a bunch of built-in judges, and there's actually even more that I'll talk about later. Things around, is the response correct or relevant? Are the intermediate tool calls kind of correct? Are you retrieving the right documents? All sorts of custom judges, and also soon third-party integrations as well. But I would typically recommend you start simple with simple high-level judges that approximate your business value, and use all these other things as almost like root causes to figure out why is a given a conversation going poorly. Maybe some of you have kind of run into this. So you have a chatbot, and then it just like users start seeing that you just start giving the agent starts giving the same response over and over again, and you see human frustration. And this is something that if you just look at each individual kind of back and forth, you wouldn't capture the trend that there's a repetition. So that's kind of why, like, when you think about multi-turn, there's a separate set of primitives you got to use. And so what we've seen a lot of customers do is kind of have a layered approach. So you first have some conversation level evaluations, and that gives you a sense of like, how is the agent doing overall? So common things you'll measure are like, is the agent repeating itself? Was the human frustrated? If it's like a support chatbot, often there's like an escalation path, so you can measure that as well. Now you know just generally how well your agent is doing. And we have some built-in judges to address that. And then on top of that, you can have these single turn evaluations as well. So probably the most popular ones relate to the actual tool call success rates, or like, are you calling the right tools to begin with? Or if you have a retrieval step, like how relevant are the retrieved chunks to the actual final response? And these all map to kind of one or more MLflow judges as well. So kind of taking a step back, really the approach here is to figure out how do you get automated evals to identify these problematic conversations, and then you can identify fixes to actually come up with some solutions. And there's a manual way to do it, and we have some like preview features to actually automate some of this with agents, which I'm not going to get to today. But if you're interested, happy to chat with you afterwards. And then finally, there's kind of how do you actually test and evaluate, and this is really kind of a lot of the current work that we're focused on, is how do you build the right simulation agent to actually figure out, if you have an improvement to the agent, how do you simulate the rest of the conversation, and is that resulting conversation a better outcome? And kind of a lot of the thinking that we're doing is around how do you figure out what all the different personas are in across your conversations and create individual kind of agents to simulate those personas. So yeah, I'll share this slide deck. The slide deck also has kind of a quick recording of this as well. Okay, so let me see. Okay, yeah, people can see this. So I have just a quick notebook here. Really what this is doing, I'll just walk you through what it, can I make it bigger? No, I don't think so. So, okay, so I'm just gonna run through this. Basically, this is just like some boilerplate that I'm gonna run through just to set up the environments. But what this is gonna be doing under the hood is it's going to configure, you'll see that I'm using this autolog call, as I mentioned. So that's all I need to do to kind of really kickstart open source MLflow. It'll create kind of a database. It creates this experiment name called customer support v2 is kind of what this is called. And then I have some like kind of boilerplate logic that I'm not going to bore you with, but really what it's doing is it's simulating conversations. So I'll have like a given like initial prompt. I'll pretend to be a user and kind of respond to it. And under the hood, it's going to call into OpenAI to kind of try to give those responses. So if I do this, you'll see one of these these conversations of like, my printer won't turn on. And then like the agent responds with some ideas. And then the user's like, oh, I've checked through some of this stuff. So there's kind of a back and forth conversation. Now you have a lot of these. How do you actually see these? That's when I'm going to go here and just turn on hit MLflow UI. So this is just going to spin up a local version of our UI. And now I'm going to be able to see this is basically what MLflow is going to generate for you automatically. And you'll see that there's this kind of tab called sessions. So I've just had one conversation. I can see that in this, there's one kind of session ID for that conversation. And once I click into it, I'm going to see this entire conversation kind of turn by turn. So and so super easy to see. I don't need to like really go through that big blob of text. I'll see everything as coming through. So, and right now it's kind of bare bones, and we're going to add more to it over the demo.
So one of the challenges in some of the agents is you want to mask the PII data or any customer data, PII, not
Yep.
PII. And is there any facility to do that without somebody coding, this is PII, this is...
Yeah, so is the question on like, how do you redact PI from this actual interface?
The tracing and the whole part of it. Right?
Yeah, so I mean...
You don't want to lose the trace without showing, but you don't want to show any customer data or PI data or any sensitive data.
Yeah, so I guess the way that you would hook into this is like, because it's using OpenTelemetry on the hood, you can hook in a separate span processor. So that lets you kind of like add some logic in the middle. I would say another team I work on focuses on actually specifically PI detection and redaction of that. And for that, we've built a separate agent to do this. But I think it's just like PI is a very company specific problem. Like every single country, every single industry has its different set of PIs. So I think it's hard to generalize that. It's probably going to have to be company specific. Okay, so then kind of next, so I'm going to showcase like 2 custom judges. Not going to go through this, but really high level, what this is doing is I can templatize this conversation. This is one of the inputs into the prompt. And so there's a bunch of things you can pass in. But what this is telling MLflow is like this entire conversation, there's an agent under the hood that's figuring out like dynamically which parts of the conversation to pull to best evaluate this instruction. And we're going to be making these kind of tool calls under the hood for each of these judges. You can also pull like individual traces or whatever in these judges as well. As kind of part of the how do you create a custom judge within MLflow. So I have these two kind of, is this conversation coherent? Is it flowing logically? Is one judge, and the other one is it retaining information from previous kind of chats? Then I'm going to go ahead and create those judges. This is kind of that MLflow API I was talking about. Can I zoom in? It's called Make Judge. And there's actually a lot of cool APIs here too that I can't get into. But one of the cool things just to highlight here is you can create a judge and then you can align it with other evaluated traces, and it's going to figure out how to make this change the judge prompt itself to better give you those evaluations that you want. Then I'm going to call this to actually pull some of the traces from my backend. So I'm calling MLflow search traces, as I mentioned before. And you can see, I can see now all these traces that were in that conversation. Then I'm going to call this GenAI evaluates, and it's going to take, a couple of seconds because it's going to start kicking off these like LLM calls. But shortly, we should be able to see the overall evaluation. So now I can go back to the UI and actually just go back into that same page, and I'll see that there is now these new things that like conversation coherence. Yes, it is coherent. And also the retention, it's good. It's not great. And I can see actually underlying what is the rationale for this by going to this full trace view. So I can see that in this case, for example, it's noticing that I generally did a pretty good job, but there was some repetition that it had. And so it's not giving me an excellent, it's giving me just a good response. So just to kind of taste of like what MLflow can do, that's kind of all I really have to show for this multi-turn demo.
One question is, so LLM as a judge is very scalable and good.
Yes.
How do you, this flow, how do you allow human to come in and, okay, let me see what you are judging, influence it, right? So like a product owner.
Yeah. So
doing it, let me just influence it. So the scale is taken by LLM, but the human in the loop is still there, and it's kind of
So
not preferred kind of stuff.
There's a couple of approaches that we have for this. Just one of the examples here would be like, if I go back into that conversation. So if I go in here, you can actually see that there's a way to, where is it? There's a way to add assessments. Where'd it go? So if I go in here, I can actually do some labeling here. So that's kind of like one hacky way to do it. There's also other UIs we've built. Often what we've seen is just that there's no one good UI for everyone. So we have like templates that will often have customers use to generate with Cloud Code or whatever their own business specific feedback.
And that will be persisted and that becomes.
Yeah, and then they deploy that, but it'll call into these MLflow APIs, so it all kind of feeds into the same system. Yeah.
Do you guys allow for optimization over MCP servers or tool descriptions? Up a DSPy style stuff.
When you say over MCP tool descriptions, what do you mean by tool descriptions? Like, is it metadata or is it information?
Like when you have the annotation of whatever keywords, the arguments that you pass in, and oftentimes if those aren't well written, the agent doesn't know which tools.
I see. Okay, built out of the box right now. I think you'd have to use DSPy separately for that. DSPy also has some job optimizer, but I'd be curious to learn more about your use case. Yeah. Cool. I think that's kind of mostly it that I want to cover. Let me go back to the slides real quick, just so this is actually just the same demo. Stuff that we're working on, I covered a little bit that we're working on simulation. There's also a lot of stuff that we're doing on our red team testing, which is kind of similar to simulation, as well as automatic like issue discovery. So you can imagine maybe you have some multi-turn conversation judge that gives you some high level which conversations are going poorly. Then you can use an LLM, an agent to figure out like which of these, what are the different classes of issues that you might want to look into. So we have already previews of that as well. And I guess just to recap, I think MLflow is generally helpful for both when you're kind of initially vibe coding that app as well as when you're trying to scalably improve agents. There's kind of the auto log thing to get started. There's a bunch of kind of other ways to get started today as well. But I leave you with kind of these two QR codes for just how to get started, as well as a link on the bottom, which has a link to these slides. So you'll be able to look at all this in your spare time.